Today we're combining a couple of sections, 4.2, 4.3, and 4.6, because they all talk about the same idea, same concept, and we're going to talk about ways to prove triangles being congruent. But before we talk about triangles, I want to reiterate how to mark correctly your diagrams. So two problems up here that give you some keywords. The first one is midpoint. And so when it asks if B is the midpoint of AC on a number line, we have to remember how to mark that. So if B is the midpoint, we're in the middle, you're going to mark the two little notches there to indicate that B is in the middle of that line segment. Now we're going to tomorrow talk about writing proofs, and this would be a step in the proof. That would be step one, and then what follows every time after you see the word midpoint is you writing that AB is going to be equal to BC. The length of AB is equal to BC. All right, number two talks about an angle, and when you see the word bisects, you need to know what to mark on the diagram. If BD is bisecting the angle, you're actually marking that the angles are congruent, okay? So this would be step one in a proof. Step two that always follows would be that the angles are equal. So angle ABD, and I'm going to say is congruent to angle CBD. So anytime you see bisects, that allows you to mark those angles congruent. Whenever you see this notation there, that means perpendicular. Okay? So when you see perpendicular, this would be step one, step two, and then actually in perpendicular, there are a third step that has to follow. So it's kind of the weird guy. But anytime you see perpendicular, you should know and remember that you're going to be marking those 90-degree angles. But it has to tell you that it's perpendicular. So after we mark that they're perpendicular with our boxes, we can state for step two that angle ABD and angle CBD are right angles. And then the reason why we can say that they're right angles is because they tell us they're perpendicular. Once you know that they're right angles, then we can go ahead and go to this step where we talk about the measure, that the measure of angle ABD is equal to the measure of CBD, and we know that they're all equal to 90 degrees. So that will always follow in a proof if you see perpendicular. The last thing we're going to review with marking is different angles that you're going to see in these proofs. So I went ahead and drew the transversal in our two parallel lines, and we have some angle pairs that are going to be congruent. So the first one I'm going to talk about is angle 1 is equal to angle 3. And if you look at that, angle 1 and 3 are corresponding angles. So we know that we can mark those congruent. So that's one pair that you'll see quite frequently in these sections. The second one deals with angles 2 and 3, but remember 2 and 3 doesn't mean just parallel, so I'm actually going to mark this down here. Angle 2 and angle 3 are equal because they're vertical angles. And then the one that is one of the angle pairs that we talked about is also listed up there, and that is angle 1 and angle 2. So angle 1 is equal to angle 2 because they are alternate interior angles, and I'm just abbreviating. So we'll be using all three of these angle types within our proofs in a triangle today. So what I would like you guys to do, this is the bulk of the lesson, is pause it and copy down. There are 5 ways to prove triangles are congruent. And when we say there are 5 ways, these are kind of like the shortcuts that you can use to prove that two triangles are congruent. You need to make sure you're paying attention to all the markings. So the first one is SSS, which stands for side, side, side. If you notice on these two triangles, all 3 sides are marked congruent to each other. I don't know anything about the angles, but as long as I have 3 sides marked congruent, then we know that these two triangles are congruent. Likewise with the others, angle side is SAS. Now if you notice, the A is in between the 2 sides. So here, the angle that's marked congruent is in between the 2 congruent sides. All right? We don't know anything about side B, C, or DF, but that's okay. As long as we have these 3 things marked, we know that those 2 triangles are congruent. Now, AAS and ASA, they're very similar because they both have 2 angles that are marked congruent, but they're in different locations. So for instance, for angle side, the side is not in between the two angles. It's on the outside, okay? And actually, you could have marked those two because this still would be side, or angle, angle, side, okay, in that order. So if you see the markings, oops, I erased everything there. If you see the side on the outside that's not in between, you have to choose this order. Now, down here, the side is literally in between the two angles that are marked congruent, okay? So it has to be this order, either angle, angle, side, or angle, side, angle. And we'll do some practice on marking and making sure the order is correct. The last one is completely different. There's no angles, there's no sides, because it's called hypotenuse leg. And it only deals with right triangles. So you have to have a right triangle to do hypotenuse leg because the hypotenuse is always labeled across from the 90-degree angle, the right angle. Now the leg is actually both of these. So we call either one of these the leg. So as long as we have a right triangle and a hypotenuse and a leg marked congruent in both, then we know that these two triangles are congruent. So these are shortcuts. Instead of proving all 6 parts, we technically only need 3 or 2 parts congruent. So we're going to go ahead and practice marking our diagrams. Here is a very standard type of diagram. Here's 3 different things, and these will be kind of like the givens, okay, in the statement, because we're going to work tomorrow on proofs. But let's look at the first one. It says given S is the midpoint of RT. You always go ahead and read through all your givens and mark correctly. So if S is the midpoint, remember we talked about marking these sides congruent. So we know those 2 sides are congruent. Next, they just tell us here that RQ is congruent to side QT. So that's all that we're given. We're not able to go ahead and mark that might look like a 90-degree angle, but you can't just assume it if it doesn't tell you in the given. So right now we have a side and a side marked congruent on both of these. So that's not enough information to prove that these triangles are congruent. But in this diagram, there's something that you're always allowed to mark congruent, and that's the reflexive property, okay? Which is technically on this one a shared side. So when we're looking at QRS and QTS, the shared side, that's the same side in both triangles, is QS. So by the reflexive property, I know that that's congruent to itself. So are triangle QRS congruent to triangle QTS? Yes. If so, by what? Well, we have 3 sides marked congruent. Side, side, side. So yes, by side, 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 or S, S, S. That's the first one. The second one gives us some other givens. It says QS is perpendicular to RT. So now I'm able to mark that 90-degree angle. It also tells us once again that QR, side QR and side QT are congruent. So that's what they give us in the givens. We can't mark anything else yet. But just like we did over here, we can do the reflexive property. So I'm going to go ahead and mark the reflexive property on my diagram. When I see this, first off, since it's a right triangle, I always tell you guys to check for HL first. But it's not always going to be HL just because it's a right triangle, but it's really good just to check first. So let's take a look. We have our H in both, so our hypotenuse is labeled. And do we have a leg? Yeah, we have the L in both. So actually in this one, these 2 are congruent, yes, by HL. So our third and final one, go ahead and pause and see if you can do this on your own and then get the right answer. So QS bisects RQT. That means this angle, those angles are bisected, those are congruent. It also gives us that these right angles are there because it gives us perpendicular. The last and final thing we're allowed to mark is the reflexive property. So now this is the only thing allowed marked on your diagram. Are these triangles congruent? Yes, by the order angle, side, angle. Because if you notice, here's our A, this is our S, and here's our A. So angle, side, angle, that side is in between the 2 angles. All right, so let's look at another diagram. Hopefully you're picking up on the concept of this, that you can't just keep marking things. So let's go ahead and mark DC and AB congruent, because that's the first part of the given. The next part just says angle A and angle C are congruent, okay? So now that we've done that, we have an angle and a side. So that's not enough information, but hopefully you can see we have a shared side, the reflexive property again. So so we can mark that middle. So let's go ahead and look at the order of our triangles, and I'm just going to redraw this out to the side, so if it helps you, we have a side here and that angle marked. So if we look and see, we have side, side, angle, okay? Going around this way. The angle is not in between, so side, side, angle. Is that one of our 5 ways? No. So that means these are not congruent, okay? The order does matter, so that one is an instance where they're not congruent. Let's take a look at the next one. It says AB is parallel to DC, okay? When we have parallel lines, remember we have that transversal. This is always going to be our transversal in this type of diagram, okay? And then what I tell you guys to do is outline, so you get this little Z. You're just outlining your parallel lines and you have a Z that's forming. Remember, I told you we either have alternate interior angles or corresponding angles within this diagram. So looking at what I've just outlined, we actually have alternate interior every time. This angle here and this angle inside my Z are going to be the alternate interiors. You cannot mark this angle and this angle because this line here is actually not marked. That side AD is not marked, so it's this entire angle, which is outside of our triangle. You only mark what's inside the Z with the parallel lines. Okay, so I'm going to erase that, and we'll take a look. So we have this angle and this angle marked because of parallel. Every time you have one parallel line, okay, you have one pair of angles congruent. Alright, so that's just a little hint. Now the second part says AB, that side is equal to DC. So not only are they parallel, but they're equal also. And that takes care of all the givens. We're not done though because we have that shared side that's in the middle. Okay, and now if you look at the triangle and the order of our triangle, I'll just redraw it out to the side. We have an angle here, a side, and an angle. So if you notice, the angle is in between the two sides. So yes, these are congruent by side, angle, side. Okay, the angle is included in between those two sides that are congruent. All right, so this is very similar. It's just kind of slanted. So let's take the time to mark AC, or angle A equal to angle C. And now we have that parallel again. So AB and DC, let's trace our Z. Tracing our Z gives me these two angles inside the Z, okay? So that's all we have marked congruent, but once again, let's mark the reflexive. So I'm gonna redraw one of the triangles just out to the side so you can see we have this marking. So now we have angle, angle, and we have the side that's outside of the two angles. So yes, these two are congruent by angle, angle, side. Now if you wrote side, angle, angle, that's still correct. You're just writing it backwards, that's all. All right, so let's take a look. We're given that two pairs of parallel lines. We have AB and DC. So I'm going to draw out my Z, just like we did before, so that gives me this pair of angles congruent. Now, we also have AD, this pair, and this pair. We still use the transversal, so I'm going to do that in the red. So my Z is tilted sideways. And now we can see that we have those two angles that are both alternate interior angles. So when you have two lines parallel, you get two pairs of alternate interior angles. So it kind of makes it easy. You can just mark both immediately. So now that we have both of the givens, the last thing we can do is that reflexive property in the middle. So I'm going to go ahead and redraw the one triangle out. We have this, this, bam, bam. So now we can see angle, side, angle is our order, which is one of the ways. So yes, by angle, side, angle. Okay, almost done with some of these diagrams. I call this my bow tie, so it kind of looks like a bow tie. The first one says E is the midpoint of CB. So make sure we're marking our lines, not angles. And it also tells us that E is the midpoint of AD, so I can actually mark those two sides. So now we've done both of our givens, but we only have two sides. This is the second thing that you're always allowed to mark if it's in the diagram, and that's vertical angles. Okay? So you don't have to be told in the given, but you can always mark our vertical angles just like so. So are these two triangles congruent? Yes, by side, angle, side. Side, angle, side. Okay? The last one on here is E is the midpoint of AD, so we're marking that, but it's not the midpoint of the other, so we can't mark both. And on this diagram, we have parallel. So with parallel lines, remember we talked, we either have alternate interior or corresponding. Well, actually in this diagram, both the lines that I'm going to highlight here are the transversals, okay? And we have alternate interior angles within this diagram. So if you can see that Z that I traced out first in the solid line, and I'll go over in red, use your Z again, and we put the angles that make up the Z there. So those are alternate interior angles. If we use the other line here, we also have these two being alternate interior angles. So I know that's a lot of stuff marked up there, but I'm going to erase some so we can kind of see what our markings are like. So we have angles A and D are alternate, and B and C are alternate. Plus it gives us that E is the midpoint of AD. So I'm going to mark all that. Now if we take a step back and look, we actually have enough information to prove these triangles congruent without marking the vertical. If you see the order, angle, angle, side. So angle, angle, side would be our way to say that these two triangles are congruent. But if you just mark the vertical first, which is okay to do because they are equal, you could have another method. If you notice, if you mark vertical, you have angle, side, angle here. So either way works. Oops, angle, side, angle. Just depending on if you use your vertical angles there. Okay, so you would have gotten it right either way. Last one for the day is kind of like our mountaintops. I say this one's kind of flipped upside down. It gives us a lot of things here that are parallel. AB, so this side, I'm going to trace out, is parallel to DF. Okay? This will always be the transversal in these type of diagrams. Now, we used alternate interior a lot, but we haven't used corresponding. Corresponding is the one in this type of diagram. If you see the blue outline, and hopefully you can identify that these two are corresponding angles within our triangles. Okay? So we have the angle there, marked congruent, angle A, and angle EDF are congruent. Now, so that's that one. We're going to do BC. So that's this side of our mountain is parallel to EF, that side. And we can still use the same transversal. Okay? And now when you see it outlined, it's still corresponding angles. It's going to be this angle at angle E and angle ACB that are going to be corresponding. So that's what we can mark congruent with our parallel. Finally, it tells us that AC is equal to DE. So we can just mark that. And if you, hopefully by now you're picking up, we have angle, side, angle as our order. So yes, these are congruent by angle, side, angle. Okay? So here are two questions I just want you to answer and bring back to class tomorrow. It says, name the two triangles that are congruent by angle, side, angle.